Hey man! It's not recording!
You have to press the right switch.
I did, man!
The other one, press the other one.
It just doesn't work!
Here, you have to press here.
Now it's recording?
Oh, sure, just ask me next time. Hey guys, how's it going? Welcome back to another episode of Head Crashing Informatics. And today we're talking about performance and in particular the performance of modern Java when it comes to I/O. Due to internal optimizations, every generation of Java is executing the same code faster than the one before. This holds true for most generations. Maybe not for every, but for most. But there also are optimizations in the API, which means you can do things more easily or you can do more things. So every generation of Java has new APIs. In this video, you will see a comparison how easy it is to load a file in modern Java compared to old Java generations. But is it worth overhauling your existing code and replacing the old API by the new API? Apparently it was already written, so you don't have a benefit from the comfort of programming. Maybe there is a benefit in the performance? Let's measure it. I'm using JMH, the Java Micro Benchmarking harness from OpenJDK, and it allows us to do a very precise measuring because measuring is always a bit tricky on Java due to the warm-ups and all that. So we hope that JMH will provide the means to provide precise numbers. And I have provided a lot of different implementations depending on the Java version, and inside the Java version what your kind of programming style is, if it is a stream or if it is a reader, or if you want to work with strings or want to work with complete files. So the code is like this. What a code does, simply spoken, is we're copying files a lot of times within a given time span. We're starting with small files, going over medium files, and we're trying to do that with huge files, and we're measuring how often we can do that. So we need files. We do this here in the setup method. It's always a new file so that we don't get the effect that is already loaded in cache. And here we are destroying that file to be safe that we have free disk space after copying a lot of huge files. And here we see in Java 6 we had to provide this very complex construction because there wasn't a try with resources. So we have to rebuild this in this way. This is what our original code would look like if it would exist. So next is that we have provide the actual name of the class, because there is no facade where we get just some input stream. We have to say exactly this is a file input stream and this is file output stream, and then we do a loop. And the same happens here. Also in Java 6 we could do this with readers and writers, and if you want a buffered version you need to write buffered reader and buffered writer. So this is what we did learn in school 20 years back. Then with Java 7 there was a new I/O system, and the new I/O system was non-blocking, and it had a facade which allowed the implementer of the JRE to optimize it. For example, what we can do here is we say files new input stream, and the Windows operating system, for example, is different than the Linux operating system, and there are different file systems. So this new input stream can decide what type of optimization I will get finally on my laptop on Windows 10 NTFS, for example, in comparison to running the same code on Linux or on Mac or on a mainframe system, for example. So this is nice because it allows the code to stay the same, but the implementation to be replaced by the JRE vendor depending on a specific file system. Should perform much faster because it allows specific optimization. And the same we can do with readers and writers, certainly. And in Java 7, this is a great one. We were allowed to load all the bytes of a file in a bunch and also write them in a bunch. That should be very much faster than doing a for loop. Let's see how that compares. In Java 8, we had the same for lines, which means we are getting a collection of strings, which is nice when you need strings. So let's see how this compares. And then since Java 9, we had a really brilliant method, which is input stream transfer to output stream. All right, that is great. So we don't have to care for anything. We just say pipe everything over there. And it can certainly internally optimize of the JRM, but also there might be a shortcut inside the JRE that allows to offload the complete operation to the file system. Who knows? It opens the possibility, and we don't have that possibility when we force every byte to walk through our code. So this should perform rather well. And then with Java 10, the same idea was applied for readers and writers. So this should be also pretty cool to simply say we don't want to have actually the characters loaded into the VM, but it should just magically be forwarded and we don't care how to. And since we don't care, it could be offloaded to the operating system. So this should also be pretty fast. And since Java 11, we could write and read all the content of a file in a single string. If we need that, that is very handy. But how is the performance of that? Let's see. And finally, if we want to copy a file, since Java 16, we simply write Files.copy and everything can get offloaded to the operating system. So this should be the fastest way to copy a file, because what a JRE can do here is it simply tells the operating system, hey, just copy that file, just like doing CP on the command line or the copy command. And it does not load anything into the VM, and so this should be really, really good performing. If you never worked with JMH before, there's one caveat. You need to be sure to always package your code, because there is an annotation processor which creates code, so you need to recompile and package before you execute. You need to be safe to really have the latest code. So I'm doing a clean package here. And it compiles not only my code, but it also added that generated code. So I will get the configuration of the JMH now executing the 3 different versions, small, medium, and huge files. So having said that, the next thing we need to do, I'm using the exec plugin to simply start the compiled application, and the compiled application will first start or bootstrap JMH and then do all the tests. So let's run. And what we see next is that actually it tells us the execution time is expected to be more than 4 hours. So actually, yes, that's just because we want precise numbers. We repeat it again and again and again with different algorithms and different sizes, and this just needs times, even on this really, really fast laptop and on this really fast SSD. So let's skip the time and just see the results. For a better understanding of the numbers that JMH provided us, I hacked all of them into a spreadsheet application and draw this nice chart. So you find here the size of the files, and you find here the throughput per second. Actually, don't care for the numbers, only care for the lines, because what we want to know is not exactly what was the throughput at a specific file size. We actually want to know, is there a difference between the APIs? And this is what you find here on the right side. So what I did is the dots is the APIs that work with bytes, and the lines is the APIs that work with characters or strings. And the thick line is an API that works with the complete file. Inside of the Java versions, we have the dotted variants and the line variants. And also I have used the colors to reflect the Java version. So in this dark blue, this is Java 6. In yellow, we have Java 7. We have in light blue Java 8. And in green, we have Java 9 and 10. And we have Java 11 in red and 16 in orange. So now look at the chart. The fastest way to copy files, who had guessed that, is completely offloading it to the operating system. So when you're on JDK 16 or further, then definitively go with Java 16's Files.copy command. As you can see, it completely outperforms all the rest. And if you have huge files, it even outperforms it massively. So this is the way to go when you want to copy files, full stop. But looking at small files, you will see that there actually is an API that is faster for small files. And this is this dotted line in yellow, which is a loop using Java 7 new input stream. That's pretty interesting. It's not Java 11, 10, 9 or something. It's Java 7. Directly below it, you will find this dotted line in blue, which is Java 6. This is interesting. So Java 7 is faster than Java 6, but Java 6 is actually faster than the others. That's pretty scary. We have here a dotted line of Java 7's read all bytes, which actually is scary because if we tell the operating system we want to copy the complete content, this apparently is slower than if we're going step by step. And why is that? This is a simple trick. This step by step just needs a small amount of memory inside the Java virtual machine. So we load data in the memory, push it on disk, load data memory, push it on disk, and so on and so on. Nothing happens. But here, we want to load complete files in memory and look at the numbers. We're beyond megabytes. So what happens here is that GC happens because we are loading huge numbers into memory and throw away the memory. Then we recreate memory, load huge numbers into it. So this is because we have GC running here. At least I think that's the case. The green line here is Java 9. Oops! Java 9 actually is so much slower than Java 7, and in particular compared to loading all the bytes. That's strange. I think this is a bug. We should actually talk to the OpenJDK team about that. So all the others here is about strings or characters. And now let's see what happens with characters. We see first characters are much slower than bytes. And the reason is clear, because we have to interpret the bytes, turn them into characters by applying a conversion. In my case, it was UTF-8. And this needs time, actually. So this is the difference you can see here. This is just the conversion between the bytes and the characters. So the fastest way when you want to go with characters, this is Java 11's files read string. So this is what we actually expected, because there are some operating systems where you can offload this, and Java doesn't have to apply this on its own. You simply tell the operating systems, I want UTF-8, and Java gets UTF-8 ready-made. Great, so go with that. But look at the other lines. We have here Java 10's reader transfer 2. We have here Java 7's new file reader. And directly below it, you can see there's nearly no difference to Java 6 doing the same without optimization. So actually, they seem to have changed the API to allow internal optimization from 6 to 7. but apparently there is none. At least on Windows. And here, this line is Java 8 read all lines, which is strange. Because if we say we want to load everything in one bunch, it should be faster than loading it in a loop. But stop. Again, here we need huge amounts of memory, free it, do GC, reallocate it, pull the data into it, and so on and so on. These ones don't do that. They simply pipe small amounts of memory in an iteration. So the difference you can see here is GC, I think. So coming back to the original question, is it worth using always the latest API, and is it worth backporting it into old applications? Well, there is no silver bullet actually. I would say if you develop new applications, always use the latest API that is made for your specific case. So if you want to copy files, use Files.copy, full stop. But if you want to load bytes in memory, you need to know if you actually want all the bytes. Then it's a good idea to use read all bytes. And it's a good idea to say read string if you want to load the whole content as a string. There is no faster way. But do you really want it in memory? If you don't want it in memory, if you just want, let's say, a filtered part of it, then maybe it might be a better idea to go with stream still. But there is no use in Java 6 anymore. You can go with Java 7's API definitively. It will outperform Java 6 always. And you have to decide if you really want bytes or if you really want characters, because characters are so much slower than bytes. So it depends on what your code does. There is no silver bullet. Another thing you have to think about is backporting into an old application may pay off more if you have to maintain it for a long time, and if you maintain it for a lot of users, and if you want to maintain it for different operating systems, because there will be optimization in future. At least there is a possibility. If you have handwritten code, it will never get faster, never. But if you backport these new APIs, at least you have the chance to get an optimization for your operating system, for your file system, and on your Java levels. So, to sum up, you need to think what your current code actually tries to do and how it tries to do that. Maybe it is using streams where you don't want them. You just want to load everything in one place. Maybe you want to have the streams. So you have to decide on your own actually. But in common, you can say that using the latest APIs, even in old code, does not do much harm, except for side cases. And there is two side cases. Side case number one. Java 9 seems to have a real problem, not the Java 9 VM or runtime, but the API it provided, the transfer to. This seems to be rather suboptimal. And the second side case is very small files have a complete different behavior than large and very large files. You can see here, the very large files have this cut over, where one API outperforms the other. And very small files might be better supported by some older APIs still, which I would rate as a non-optimization in the new API. But you need to be careful with that. If you're really only using lots of very small files, the world looks a bit different than this chart. So my personal advice is, go with all the new APIs as soon as you can in new code. And if it's worth it, go with it in old code, but you should think over whether it's worth it. And by the way, looking at Windows and Linux, you will be scared more This is how Windows performs, just some selected APIs, not all. And look at that yellow and red lines on Windows. This is how the Java 7 streams compare to the Java 9 streams. And I said there seems to be a missing optimization inside of that API, because certainly it cannot be true that a loop in the virtual machine is faster than it cannot be the case that a loop in my application is faster than a loop in the JRE. But now let's look at Linux. In Linux, the difference is not so huge. So actually, it seems to be Windows dependent. Still, it is badly optimized, apparently, but it depends on the operating system and possibly on the file system. So it seems we should give the OpenJDK team a call and ask how that could be that an application loop is faster than a JRE internal loop. That is definitively a bug, I think, and I will try to debug into that and let you know the outcome. What you definitively should not do, let me tell you that. You should not take that numbers as granted and now try to write a workaround about the Java 9 behavior inside of your application. That's a really bad thing, because one day they will fix that problem, because it's clear to everybody that a loop in the JRE must be faster than a loop in the application code. And once they do that, you're screwed, because you don't get that optimization for free then, and will stick forever with the performance you provide in your application. Because again, an application compiled code cannot be further optimized. It will always do what you see on screen. And certainly, you're completely cutting off any optimization that goes into the operating system or the file system. Because, as I said, the application provided code will always behave exactly as the lines you see on your source code screen. Well, the problem might be gone on Windows, and probably there's an optimization for Linux or for macOS. So you might work around a bug of Windows that doesn't exist on Linux or on Mac at all. So don't write code around these numbers. Write code depending on the target you want to reach, and ask the guys at OpenJDK to look into their numbers. So far for today, I hope you learned a lot and you can better decide whether it's worth to backport new APIs into your existing code, and I hope you learned that it's not a good idea to work around in the application code bugs that are actually inside of the JRE, because tomorrow the bug is gone and your workaround still is there, and you possibly cut off optimizations on other operating systems that never had that bug. I hope you loved this video, and if you loved it, please give it a thumbs up and subscribe to my channel, and I would be happy if you become my Patreon too. So until the next video, I hope you stay safe, and as always, party on!